Good morning, guys, and welcome to my channel, Mind Your Math. What are we going to learn today? We are going to learn how to find the digit in the units place of certain numbers. Now, what are those numbers? Depending upon the question, the number value will be easy to find, or first we need to figure out the number, because once we figure out the number, you can easily find out the digit in the units place. If this is a number, 6 is the digit in the units place. In this case, 3 is the digit in the units place. So let us say a number 3 raised to 5 is given to you and we need to find the last digit. So 3 raised to 5 is equal to 243. So I can say that 3 is the digit in the units place. If we are talking about 81 square and we need to find the digit in the units place, what do we normally do? If you are a primary school student, you will multiply, you will find the answer and then say that 1 is the digit in the units place. But if you are past primary or if you are in middle school or above that, what do? We know that the last digit comes from the multiplication of the last digit of these two numbers. So, since we are only bothered about the last digit, what do? We multiply the last two digits and say that 1 is the digit in the units place. Suppose we have a number 35 into 36. What is the digit in the units place? We multiply the last two digits. So 5 into 6 should give us a 30. 3 goes as a carryover when we are doing the multiplication or addition. So 0 is the digit in the units place. Let us take a couple of numbers, normal multiplication, and figure out what would be the digit in the units place and get a start to this particular tutorial. Let us check the value of the last digit of the number that is resulting from this. Okay, the first one is 800 into 3 raised to 247. Now, you know that whenever you are multiplying any number, however huge the number is, with another number whose last digit is a 0, the answer also will have 0 as the last digit. Now, whatever be the value of this number, so let us say this is 3 raised to 2. This basically becomes 800 into 9, which is 7200. The reason is because there was a 0 over here, which will give us automatically a 0 in the last digit of the answer. So 3 raised to 247 into 800 will have 0 as the last digit. Second one, 343 into 867. Whenever we need to find only the last digit, we are bothered only of the last digit of the numbers which we are being multiplied. So 7 into 3, which will give us 821. The 2 goes as a carryover. So 1 is the last digit. What is the last digit in this case? 9 5s are 45. 4 gets carried over. So 5. This is basic. Whenever we are multiplying two numbers, we can find out the last digit in the answer by looking at the last digit of the numbers which are being multiplied. I hope this is very clear to you. It is very basic and it is just based on number crunching and multiplication. So now let us move on to the next part. Now let us have a look at these kind of sums. Find the last digit or the digit in the units place of this particular number or this particular combination, this or this. Now these kind of sums do not normally come in our academic curriculum when we are practicing this for schools or when we are studying in schools or colleges. You must have seen these questions only when if you are practicing for competitive examinations or you have already appeared in any of the competitive examinations. These kind of sums, when we look at it, we feel it is very difficult, but this is one of the easiest. It is extremely easy that it is really interesting to solve also, and in no time you can solve this. So now let us see how we can practice or how we can do these kind of sums. Let us have a look at this multiplication table. This is not our conventional multiplication table. This is a multiplication table of the powers of 2. 2 raised to 1, 2 raised to 2, 2 raised to 3. I have written up to 2 raised to 8. Why have I written it? I have written it so that I want you to observe this multiplication table and see if there is any pattern. For your convenience, I have marked the last digit of each number because we are concerned about finding the last digit. Now you can see that 2486. 2486. There is a pattern that is being repeated after the fourth power, after 6. Again, 2486 is being repeated. So if you write 2 raised to 9, 2 raised to 10, 2 raised to 11 and 12, you can see that again the last digit follows the same pattern, 2486. So what can you say about this? The last digit in the case of powers of 2 repeats after every fourth power, or I can say that 2 has a cyclicity of 4, or a period also, I can say period also of 4. So the cyclicity of 2 is 4, which means that after every fourth power the last digit repeats. Okay, now let us see how this is going to be useful for us in order to solve a sum. Since 2 has a multiplicity of 4, I can say that every fourth power will end in 6, right? So 2 raised to 4 ends in a 6, 2 raised to 8 ends in a 6. Now 2 raised to 12 ends in a 6, the reason being 4 into 3 is a 12, and therefore the number ends in a 6 because every fourth power it repeats. So I can say 2 raised to 16, it ends in a 6. So whenever you have a power of 2, because the 2 has a multiplicity of 4, we divide the power with 4 and see whether it is completely divisible. If it is completely divisible, I can say that the last digit will be 6. Okay. Now, let me ask you, 2 raised to 180. Does this number end with a 6 or not? Now, I told you that I need to multiply the power with 4. So, 180 by 4, what do we get? I get a 45. So, I can say that 180 is divisible by 4 completely. Therefore, 2 raised to 180 has to end with a 6. Now, let us see what happens when the power is not divisible by 4. Let us have a look at these numbers. 2 raised to 5, 2 raised to 6, 2 raised to 7, 2 raised to 8. As you know, the power is divisible by 4, therefore it ends in a 6. What about 2 raised to 5? When I divide the power by 4, I get 1 as a remainder. Looking at the pattern, if you are writing the table for the remaining numbers, whenever division by 4 gives you a remainder of 1, you can see that the number ends in a 2. If the remainder is a 2, as in the case of 6, the number ends with a 4. And if the remainder is not divisible by 4 and the power is not divisible by 4 and gives a remainder of 3, then the last digit is an 8. Okay. Now I hope you are clear with it. First, you check if the power is divisible by 4. If it is completely divisible, you know that the number ends with a 6. The reason we are dividing with a 4 is because 2 has a cyclicity of 4. It repeats, the last digit repeats after every fourth power. Okay. If it leaves a remainder of 1, it ends with a 2. If it leaves a remainder of 2, it ends with a 4. If it leaves a remainder of 3, it ends with an 8. Okay. Now, if you have a number 2 raised to 225, what will be the last digit? We divide the power by 4. What is our remainder? 1 is our remainder. So, 2 raised to 225 will end with a 2. This is what you need to remember. See, you can also figure out by writing down the pattern or the multiplication table for the powers of 2. But when you are in a competitive examination, time, it matters a lot. So, it is always better that you remember this particular values. Now, when you are learning the cyclicity of 2, you need to understand that for a number ending with a 4 or an 8, you have a number 4, you can write it as 2 square. Okay. So, the cyclicity of 2 is applicable also for 4 as well as 8, which can be expressed as 2 raised to 3. So, if somebody were to ask you, what is the last digit for this? 8 raised to 108, you do not have to remember the cyclicity of 8. You need to remember only the cyclicity of 2, because 8 raised to 108, I can write as correct. So now this is actually equal to 2 raised to 324. Now we need to check if the power is divisible by 4. 324 divided by 4 will give me 81, which means it is completely divisible, thus giving us the last digit of this particular number as a 6. Now let us see a few more examples regarding the cyclicity of 2, and then after that we will see that of 3, 5 and 7. Find the last digit of this particular number. 2 raised to 8 raised to 92 into 2 raised to 41. Now 8 raised to 92, I am going to write it as 2 raised to 3, the whole raised to 92. Okay. Now 2 raised to 41, this will give me 2 raised to 276 plus 41, because both are having the same basis. So I will get 2 raised to 317. Now I need to check the cyclicity by divide. I know the cyclicity, sorry, I need to divide the power by 4. So 37, 9 4s are 36. I am getting a remainder of 1. From the cyclicity table, you know that the last digit has to be a 2. Okay. Now let us do another sum. In this example, I have used the same numbers, except that I have changed the sign in between to plus. So 8 raised to 92 and 2 raised to 41, I am writing as 2 raised to 3, the whole raised to 92, which will get converted to 2 raised to 276 plus 2 raised to 41. Now you know that because the sign in between them is an addition, I cannot use the same base property and combine both of these terms and write a common power. I need to find the last digit in each case separately. So power divided by 4 will give me a 69 with no remainder. So this particular number ends with a 6. 41 by 4 giving me a remainder of 1. The number ends with a 2. Now two numbers, one number ending with a 6 and the other number ending with a 2 are added together. We normally start our addition from the last digit. Suppose our number is 376 and 128. These are the two numbers that we add first. 6 plus 8 giving a 14. One gets go as a carryover. In this case, the numbers are ending with 6 and a 2. Added together, the last digit is a 8. I hope this is really very clear to you. Now let me change the question slightly. What happens if the sign is a negative sign? So it is 6 minus 2, which will give me a 4 as the last digit. Clear? Now you know how to find the last digit when 2 is raised to any power, 4 is raised to any power and 8 is raised to any power. Now let me ask you this. You have a number 28 raised to 65. You know that the number is ending with 8, but strictly it is not only 8, it is 28. So let us see how we can solve this particular sum. Whenever you have a 2-digit number, a 3-digit number, 5-digit number, any number of digits raised to a power, and we need to find only the last digit, we are bothered only about the last digit of the base or last digit of 28. In this case, the last digit of 28 is an 8. So, if we want to find out the last digit in this particular case, we need to find the last digit of only this particular number. Now, 8 is. So, what do you get? 2 raised to 195. Now, we need to divide it by 4 and see what we are getting. So, 195 divided by 4, you will get 35. I get 3 as a remainder. So I know that the last digit of this particular number or this particular number will be 8. Okay, I hope you are clear with this. When we are considering the base, we need to take only the last digit, figure out the entire power, divide by 4 and then figure out what we are getting as the last digit. Let's find out the last digit of this particular combination. I told you that 242 raised to 301, you need to bother only about the last digit. So, 2 raised to 301. In this case, 8 raised to 1311. Now, 2 raised to 301, I will divide the power with a 4. So, I will get remainder as a 1. When I am getting the remainder as a 1, I know that the last digit will be a 2. Fine. Now, let us check about 8 raised to 1311. This is equal to, correct, this is 3933. Now, let me divide 3933 by 4 and see what I am getting. In both these cases, I am getting the last digit as a 2. So, last digit plus last digit over here should give me the last digit of this particular combination as a 4. So, now we have learnt about 2, the powers of 2, the cyclicity of 2 and how to find out the last digit when 2 or 4 or 8 or any number ending with these digits are raised to any power. Okay. Now we need to check the numbers that are ending with a 3, 7, 1, 5, etc. In order to do that, we again need to find the cyclicity of those numbers. So now let us do the cyclicity of 1, 5 and 6. Why I am combining these numbers, you will see now. This is the power table of 1. 1 square is 1, 1 cube is 1, 1 raised to 4 is 1, 1 raised to 5 is 1. 1 raised to any power will end with a 1 or will definitely give 1. So I can say that the cyclicity of 1 is a 1. The last digit repeats after every single power. Okay. So when we are looking at 5, you can see that 5 raised to 1 is 5, 5 square is 25, 5 cube is 125, so on and so forth. The powers of 5 always end with a 5. So I can say that the cyclicity of 5 is also, sorry, it's not a 5, it's a 1. For every single power, the number ends with a 5. Okay, now let us check for 6. 6 raised to 1 is a 6, square is a 36, cube is a 216, 6 raised to 4 is 1296. Again, all the powers of 6 ending with a 6. So I can again say that cyclicity is a 1. So the cyclicity of 1, 5 and 6 are 1. This is what I have written over here and that is the reason I have clubbed them together. You know I have clubbed 2, 4 and 8 because cyclicity of 2 is the same as that of 4 and same as that of 8 because 4 and 8 can be represented as powers of 2. Now what are the numbers that are pending? 3, 9 and 7. So since we have clubbed the powers of 2, 2, 4 and 8, we know that we can club 3 and 9. So basically we need to find the cyclicity of 3 and the cyclicity of 7. So now let us start it. Let us check the cyclicity of 7. I have written the table over here. You can see that the powers of 7 end with the digits 7, 9, 3, 1. And after every fourth power, the same numbers repeat. So I can say that the cyclicity of 7 is also 4, just like in the case of 2. But where is the difference? When the power of 7 is completely divisible by 4, it ends with a 1. When the power is a number that is not divisible by 4, but leaves a remainder of 1, then the number ends with a 7. If the power when divided by 4 leaves a remainder of 2, it leaves 9 and it leaves a remainder of 3, the number ends with a 3. Now let us check the cyclicity of 3. You can see that the cyclicity of 3 is also 4, which means that we need to divide the power by 4 and see the digit it is ending up with. So 4 is a cyclicity means when we are dividing the power by a 4 and it is completely divisible, the number is ending with a 1. When it leaves a remainder of 1, the number is ending with a 3. When it leaves a remainder of 2, the number is ending with a 9. When it leaves a remainder of 3, the number is ending with a 7. Now, in the case of 1, 5 and 6, we do not have any doubt. It is always going to end with 1, 5 and 6 respectively. In the case of 2, 4 and 8, you know that 4 and 8 follows a cyclicity of 2. In the case of 9, it follows a cyclicity of 3. So, now we are bothered only about the remainders in the case of 2, 3 and 7. Now, let us put those values into a table and see how easily we can remember them. The numbers are 2, 3 and 7 that we need to be bothered about. First, let us see when the power is completely divisible by 4 and do not leave any remainder is a 0. We know that the number 2, whichever power it is raised to, if it is divisible by 4, it ends with a 6. In the case of 3 and 7, it ends with a 1. Okay. So, this particular value, I want you to remember it is 611, 611. When the remainder is a 1, when the power when divided by 4 leaves a remainder of 1, in the case of 2, the number ends with a 2. How do I remember it? 2 raised to 1. In the case of 3, it is 3 raised to 1. In the case of 7, it is 7 raised to 1. When the remainder is a 2, 2 raised to 2, 4. 3 raised to 2, 9. 7 raised to 2, 49 ending with a 9. Now, when we have a remainder of 3, 2 raised to 3, which is 8. 3 raised to 3, which is 27, ending with a 7. 7 raised to 3, 7 sevens are 49. 49 into 7, which is 343, ending with a 3. This is the table that we should be remembering. Now, let us follow this concept with a few sums taken from various websites, obviously, so that we get a thorough idea of this particular concept in the next video.